Hey guys, welcome back to the channel. Today we're going to be solving LeetCode 153. Find minimum in rotated sorted array. Keywords are rotated and sorted. It also asks us to do it in log n time, and I'm going to show you guys 3 different ways of doing it. The first way is kind of like a cheat method, and it's just simply to return the mean of nums. Okay, this is probably not how the problem wants us to solve it, but it works. Okay, I think it works at least. Okay, bam, we're faster than 6%. It works. But this doesn't show we truly understand what's going on. Although this is a log n algorithm, it doesn't show. Again, a second way to solve it, also a cheap way, is to sort the array. Okay, let's go back. The problem says it's a sorted array. Okay, second way is to sort it. It's sorted and rotated, so we just want to sort it again. Okay, and then after sorting it, we want to return the first index. Okay, this should also work. Bam. Okay, still faster than just 6%. Terrible timing. Very good space because we're really not creating any variables, just simply one instruction. So this works, but again, it doesn't show we understand the algorithm. Okay, so the last way to solve it, okay, every time you see log n, you want to think binary search. Okay, and what is a binary search? Let's just go and try to at least kind of get a rough idea of what this problem is asking for. Okay, I'm gonna use the example they gave us. Okay, example 1 says nums. Okay, let me get a black color. It says nums. So nums is a rotated sorted array. Okay, so simply this array was simply just this. It was simply 1 2 3 4 5, and then it got rotated to the left. It got rotated to the left by 2. Okay, which is why these 2 guys went around to the back. Okay, and that kind of led us to this array. Okay, so now we want to solve. So just to picture what this looks like. Okay, if we were to draw a graph, a regular sorted array will look something like this. Okay, this is n. Each element of the array is kind of increasing, but this array looks something like this. Okay, it's increasing to a point where it drops, starts back from 0 and keeps going. Okay, it looks something like this because he was first sorted and then he was rotated. Okay, so from this graph we realize there's a point where he's high and then he suddenly drops low at the next index. So that is what this problem is asking us. This problem is asking us to find that point where that happens, which in this case is right here. Okay, between 5 and 1. But how do we find it? How do we get to that point? It's simple. We start with 2 pointers, a left pointer, which is just the index 0 of the array, and a right pointer, which is just the last index of the array, which is length -1. Okay, then we need a mid pointer, which is just equal to our left plus our right pointer divided by 2. Okay, in this case, it's gonna be here, mid pointer. So we just have to ask ourselves a question: is nums, okay, nums of mid, is he greater than nums of r? In this case, nums of mid is 5. Okay, is 5 greater than 2? In this case, the answer is yes. So we know the point we're looking for, the inflection point where it switches from high to low, is between nums of mid, is between mid and it's somewhere between mid and r. Okay, so we can completely ignore this point, completely ignore this side, and just move L to right here. Okay, completely ignore this side. So now this is our new vector we're searching. Okay, now we have to search this guy to find the point, and obviously we're gonna find it's right here and return the point. So again, I hope this kind of made sense. If not, hang in there, we're gonna solve it. Once you see the actual code, it's actually gonna make sense. Okay, so I'm gonna go ahead and minimize this guy. Okay, so what do we want to do? Like we said, we want to initialize 2 pointers, a left and a right pointer. Okay, so L, R, so left and right pointers equals to 0, length of nums -1. Okay, we have our left and right pointers. Okay, then while, okay, L is less than R. Okay, always all binary searches follow this same pattern: pointers, then a while loop. Okay, always while L is less than R, standard. Okay, we want to calculate our mid. Again, like we said, our midpoint is just halfway, L plus R divided by 2. Okay, so mid R plus L floor divide by 2, just in case there's decimals, so we can get rid of the decimals, okay, because indices of arrays don't have decimals. Okay, then if, again, the same question we were asking right here, if mid, okay, is greater than R, same, if nums of mid, okay, greater than nums of R, okay, what did we do? Okay, what we did was we just left, I'm just gonna go ahead and put both of them on the same point. Okay, what did we do? Okay, we just left shifted, right? We just said L equals mid plus 1. Okay, now our else case. Else, this means num of mid is not greater than this. He's either less than or equal to nums of R. In that case, we're just gonna say R equals mid, just in the case where he's equal and not less than. I'm gonna say it's equal mid and not move it by 1. Okay, then if we go through this completely, we want to return nums of L, which is gonna be our lowest number. So this looks correct. I'm gonna go ahead and run this first, see if it's accepted, and then submit it. Okay, good. For some reason we didn't do too good on the speed, but again, this works. This is a different way of solving it. Okay, we know it works. Okay, so one step further, just to kind of picture what's going on. So this is the exact same function we just wrote in LeetCode. Okay, I just created a driver code to call it, so we can kind of visualize what's going on and see what's happening. Okay, so as always, we define our array, initialize nums, call the function. We initialize the function and we call the function. Okay, keep in mind we're passing the same nums into the function, so that's why it's pointing the same address in memory. Okay, so next we're gonna define our L and our R. Okay, L is 0, which is the first index, like we said. R is 4, which is the last index. These are just our pointers. Okay, then we're gonna define mid. Okay, mid is just halfway. L plus R, 4 plus 0 divided by 2. Okay, which is 2. So now if nums of mid is greater than nums of R, so in this case nums of mid is nums of 2, which is 5, which is greater than nums of R, which is nums of 4, which is 2. Obviously 5 greater than 2, so we're gonna move L should move to mid plus 1. So mid is 2, L should move to 3. Pretty much the same as you see, L is 3, same as we explained on paper. Okay, then it's gonna go through the loop one more time. Okay, so now we're looking between 3 and 4. Okay, now we're going to calculate our mid. Our mid is going to be 3 plus 4, 7, floor divided by 2. 7 floor divided by 2 is just 3, so our mid is going to be equal to our L. Okay, and in this case it's not greater. Okay, so we're just going to skip and return L. So we're going to return nums of L. So that's it for the video, guys. I hope it was helpful, and I'll see you guys in the next one.